Today we're going to look at solving some problems using the quadratic relationships. We've now looked at different forms of the quadratic relationships and what types of information we can pull from them. So as part of our warm-up, we want to identify which quadratic form is required to determine each of the following features. And so again, some of them you can solve more than one way, and I'm just concerned about what you can get quickly from the relationship. So we've got three examples. We've got vertex form, we have the standard form, and lastly we have intercept form, or what we can also call factored form. Okay, and so I'm just going to call that FF. So let's go through and identify everything we can figure out from the vertex form, just by quick way of review. So y-intercept, can't get that from the vertex form. Zeros, can't get that from the vertex form. Max value, we can get that from the vertex form. That's the optimum value, and it's actually equal to the k value. The vertex form, absolutely, we can get that from vertex form of the equation, and that's equal to the hk values. The axis of symmetry, yep, you can get that also from vertex form, and that happens when x is equal to the h value. And the direction of opening, we can determine that from vertex form based on the value of a. So vertex form is very useful. 4 of the 6 things, or 2/3 of the things that you're looking for, you can find using vertex form. For standard form of the equation, what can we figure out? Well, standard form, we can use that to get the y-intercept. And the y-intercept is always equal to the c value. Okay. We can't get zeros from standard form. We can't determine the maximum value. We cannot determine easily the vertex, nor can we determine the axis of symmetry, but we can determine the direction of opening. Okay, and so standard form, in standard form, we would determine the direction of opening again based on the a value. Finally, factored form will allow us to determine what the zeros are. Okay. The other nice thing is that factored form will also allow us to figure out the axis of symmetry. Okay. And so what you would do in order to figure out the axis of symmetry from factored form is you would take the average of the two zeros. Okay, and the average of the two zeros is what you're going to get. And then finally, you can also determine the direction of opening based on, again, the a value in factored form. So, knowing that, actually it would probably be helpful if I add in what those equations are. So, minus h squared plus k, that's the vertex form. Standard form is when y is equal to ax squared plus bx plus c. And finally, intercept form is y is equal to a times x minus r, x minus s. Okay. So, as an extension of our warm-up, let's find the minimum and maximum value for the following events and when they happen to occur. And again, that happens always, always, always at the vertex. Okay, so we have to be able to figure out, well, what is the vertex of these three different equations? So the maximum or minimum value always happens at the vertex. Happens at the vertex. So that's what we're looking for. We're trying to figure out what is the vertex. So if we're trying to figure out what the vertex is, in this case, this happens to be given to us in vertex form. So the nice thing about this is that it gives us our a, h, k values. Our a value is -2. Our h value is +1. Our k value is +12. So the vertex is at 1, 12. So the 1 tells us when it happens, when the maximum value happens, or max or min value. The 12 gives us the optimum value. Okay, so if we use that, we're going to carry on looking at the next two examples. So in the middle here, we actually have an equation that's given to us in factored form. So that will actually allow us to figure out what the zeros are. So the zeros are +4 and -6. And because we have the zeros, we can figure out what the vertex is going to be, or what the axis of symmetry is. So the axis of symmetry is going to be the average of the two zeros, so 4 plus -6 divided by 2. So that's going to be -2 over -2, or over +2. So the axis of symmetry happens when x is equal to -1. And so if I substitute in -1 into the original equation, then that will give me y is equal to, try that again. Y is equal to 2 times -1 minus 4 times -1 plus 6. So my y is going to be equal to 2 times -5 times +5. So y is going to be equal to -50. So my vertex is -1, -50. So again, the -1 is when the optimal thing happens, and the -50 is the optimum value. Okay, so the -50 is the optimum value. So if we look at the last example then, we've got a situation where we have an equation that's given to us in standard form. Okay, and so we need to figure out what the vertex is from standard form. So the way that we've looked at doing that is we have to convert from standard form into factored form, and then from factored form we determine the zeros, the axis of symmetry, and substitute back in. So in order to go into factored form, we have to divide everything by -2. So we're going to end up with let me try that again. We're going to do y is equal to -2 times x squared plus 6x minus 7. Okay, and so we're looking for two numbers that are going to multiply to -7, but are going to add to +6. So they need to multiply to -7. They add to +6. So 1 and -7 gives me -6. -1 and +7 no, 1 and -7 gives me -6. -1 and +7 will give me +6. So in factored form, it's going to give me -2 times x minus 1 times x plus 7. So now I can figure out what my zeros are going to be, because I have it in factored form. So my zeros are going to be 1 and -7, which means that my axis of symmetry is going to end up being 1 plus negative 7 divided by 2. So negative 6 over 2 is going to give me negative 3. Okay, so my x value at the vertex is going to be negative 3. And so what I need to then do is substitute back into one of the two equations. So I'm going to actually substitute it back into my factored form of the equation. And so factored form of the equation is y is equal to negative 2 times x minus 1 times x plus 7. So I'm going to substitute in my value for x. So it's going to be y is equal to negative 2 times negative 3 minus 1 times negative 3 plus 7. So y is going to equal negative 2 times negative 4 times positive 4. So y is going to equal positive 8, positive 32. So my vertex is going to be at negative 3 and positive 32. Okay, and again, the negative 3 is when it happens, and the 32 is the value of the optimum value of that particular point.